axis. In this video, we're going to be machining the Titan 200M. Before we get started, make sure that you've downloaded and printed the process document and all of the other documents related to this part. We've already completed the first operation because you should be able to take the setup sheet and what you learned in the Titan 139 video and apply it to this part and machine this first operation on your own. So before you watch this video, make sure that you have completed operation 1, and if you need any help with that, refer to the Titan 139M tutorial. Now we've already loaded the tools and the program into the machine. Now we're going to look at our setup sheet of how we need to install the part into the vise. And there we can see that it's set up the same way as the Titan 139. So Z0 is off the bottom of the part and X and Y is off the center of the part. So we're going to set Z before we put the part in the vise. Now we've probed the bottom of the vise to set our Z, but as you can see how tall this part is, and we've got a hat all the way around the material, touching off X and Y is not going to be as easy. So I'm going to show you a little trick that we can do in order to set our X and Y work coordinate. So first we're going to lightly clamp on this part where we want it in the vise and then install a vise stop. Now that I got my stop set, we actually need to set our C axis before we set X, because if we're crooked in any way, then our X and Y is going to be shifted off. Now in Op 1, we just indicated the vise jaw itself, but this is a centric vise, meaning both jaws can move, so we could have a little play there. And since we have a finished surface, we want to check that finished surface and make sure that it is in line with our C axis. All right, so now that our indicator is reading 0, we're going to go to our offset screen, go to our work, arrow down to our G54C, and I'm going to put C0 and measure. Now we can take this part out and insert a 1, 2, 3 block in order to teach our X axis. So the reason why we're using a 1, 2, 3 block is because it has a ground face. And we have it pushed up against the vise stop because that is where the face of our part is going to sit. So what we're going to do is take our probe, we're going to probe this face, and then we're going to shift it over by half of whatever our part measures. That's going to set the X-axis work offset to the center of the part. All right, so now we got the probe position, so we're going to go to the GUI screen. We're going to select probe, but this time we're going to select edge. Now up here in the top right corner, we can see edge type. And we have a little graphic display right here on the left. So if we toggle this with our arrow, we can see the display changes to select what face we want to probe. So we're going to arrow over until we see the X negative direction. Next, we're going to arrow down. Now we're going to input what work offset number we want to update. And in this case, it's 54. So we're going to type in 54 and hit input. Now all we got to do is put it in memory mode, close our door, and hit cycle start. Now after we probe that edge, we're not done just yet, because what that did is set our work offset on the edge of the part. But we need it in the center. So what we need to do now is measure our part, and whatever it measures, we need to take half of that and shift it in our work offset. So my part actually measures exactly 2.950. So half of that would be 1.475. And since I set my stop up on the right side, I need to shift negative 1.475. So what we're going to do now is I'm going to hit reset to clear out anything that might be active. We're going to go to offset. I've already got my work called up. And on my G54, I'm going to go to X and I'm going to say minus 1.475. Make sure the number is correct, and I'm going to hit input plus. That's going to ask me, is this input okay? And I'm going to hit execute. So with that, our X-axis is set, so now we need to set Y. And for that, we're going to go ahead and put the material in the vise and go ahead and get it clamped down. So now that we've set X, we need to set Y. But as you can see, we've got the same problem. We've got a hat of material hanging over both sides, and it's really tall, so we can't really get down and probe the part. But since we have a 5-axis, we can rotate our table or our B axis to 90 degrees, then come down and use a web routine the same way we did in the Titan 139. So if I take my hand wheel and I rotate this down to 90 degrees, So now I'm at B90. Now I can simply position the probe in the center of the part. So now you see the probe is positioned roughly in the center of the part, ready for the web routine. Now one thing to keep in mind here is that we want to make sure that your C-axis is at C0. So now we'll go to the control and type in our parameters for our web routine. So we're going to put it in MDI mode, go to program, make sure we hit reset a few times. We're going to go to GUI and probe. Now we're going to hit that web. Now we're going to change to Y web. We're going to set G54. The width, I'm just going to say 3 inches. That's just a little bit over what our finished size is. And for our depth, I'm just going to put in a 1/2 inch. So now all I got to do is close the door, put it in memory mode, and hit cycle start. So now we've probed our work offset, it's time to do a dry run. But as you can see, the part is so tall that we won't be able to just add 6 inches to the height and run the program. So what I recommend doing is, now that we have a vise stop set, you can remove your part, dry run the program, then put it back in to run the part. So we just completed our dry run, we got the part put back in. Now I'm going to remove the vise stop, and it's time to cut some chips. Now we're not using coolant on this part, but that's just for filming purposes. If you run yours, make sure that you run coolant. Now notice on this part, when we're on the third side, we're kind of working up that wall and it's barely even touching any material. That's because on the stock tab in our Mastercam file, we had it set to ignore small cusp and we had a 25 thousandths value in there. You can actually go back and play with that value to make this cut even more or a little less. So what it's doing is it's seeing those small cusps and thinking that there's material there to cut. So you can actually put a bigger value in there and get rid of some of these small cuts that's not really doing anything. All right, so tool 1 is complete. We've got all of the roughing finished except for the material that we left inside this pocket. Now, if you remember from the cam tutorial, we left all of this in here to give us a little bit extra rigidity. But we still have this small diameter here, but we got to finish that when we finish this top part. So we still want to look out for any chatter that we might get from this small diameter. And if we do get any, it's going to be from tool pressure. So we're going to call up tool 5, which is the ball mill, to finish this top portion. Now we went straight to the finishing from the roughing because the roughing tool was able to get most of that material off of there. But as you can see on the part, you've got a lot of different scallops on there. So that's going to mean that the material is going to be inconsistent as the tool is trying to finish. This being a soft material, it's going to be a lot more forgiving. Now, if this was a real part for a customer, or if we were making out of something that was a little bit harder to machine, we would probably go in and create a semi-finishing operation before we would come in and finish. So what we would do is we would take the same exact tool path as our finishing, except we would add a little bit of stock, and then we would increase the step over. You don't need a very small step over because it's just a semi-finishing tool path. We're really just looking at knocking down all of those scallops and making it an even cut to come back and finish with. Now that's going to make your surface finish a lot more even, and it's going to even out the tool pressure as well. Oh man, check this out. This thing is looking beautiful. Now that we've got the top finished, now it's time to come in with that face mill and face these 4 legs. Now, right here is where it's really important for your tool length to be set correctly, because that face mill and the ball mill that just ran is going to blend right here at the bottom of these legs. So if one of the tools is sitting higher than the other, you'll see a step right here. So on the face mill, we're able to check that the length is correct by checking this width of our square at the bottom from op 1. Now for the ball mill, we can actually check the diameter right here to make sure that it's correct. So as long as we check those, we get them measuring right, we should have a perfect blend right here. Alright, so now our face mill has ran, and as you can see, we got a nice blend between these two tools. So now we're going to come back in with that 1/2" tool, rough out these pockets, and then it's going to come in and finish these walls. After that, all that's left to do is bring in our ball nose tool and finish these fillets around the outside and deburr the top of the pocket. Alright, now the 200M is complete, but before we take it out, we're going to go ahead and set up a vice stop, because the first op on all of the parts in this series are exactly the same. So if you run the first op on all of the parts, now we can just set up a stop so we don't have to touch each individual part off. So we're going to set that up just how we did on this part on the right side of the vise, touching the bottom of the part. Tap it on, push over till it touches, and lock it down. Now we can take our part out and locate our next part. All right, now the 200M is complete. Now you see we could make a fairly complex part while still using 3+2 machining. Now we did introduce you into a little bit of simultaneous with the deburr, but on our next part, we're gonna get a little more complicated and introduce a lot of 4-axis tool paths as well as a little bit of 5-axis simultaneous. So make sure that you catch the next part as we take our 5-axis training a little further.